Hello, good day. In this virtual class, we essentially we're going to look at rules of divisibility for prime numbers. Divisibility rule for prime numbers. Now, a divisibility rule is a shorthand and a way of determining whether a given integer is exactly divisible by a fixed divisor. Okay, here a unique and a derived method for divisibility of prime numbers using the concept of seed numbers. It is important to understand prime numbers, odd numbers, and odd prime numbers. Now, what are prime numbers? They are numbers that have only two factors, 1 and itself. Examples: 2, 3, 5, 7, 11, till infinity. Then odd numbers, number that cannot be exactly divided by 2. They'll use that simple definition. We have 1, 3, 5, 7, 9, 11 till infinity. They will also have this one here, odd prime numbers, and that is where our classes stand on. So these are numbers who are characteristically odd and are also prime number as well. So we're going to make use of this one in generating what we call the seed numbers. Okay. Now, the concept of seed numbers. What does it actually mean here? The concept of seed numbers specifies that every odd prime number gives a unit digit of 1 and 9 in 2 of their first 10 multiple. What it simply means that once you multiply 2 odd prime numbers together, in most cases, they usually end up with, that their unit digit usually be 1 and 9. So this is what will guide us. This idea will guide us on how seed numbers can be generated for determining if a number is divisible by a given integer. Okay, the above statement we just made can be translated into a mathematical expression in two forms. 1 is I, k times 10 plus 1. Then I, k times 10 minus 1. So this number, once we find their product, you can either express them in this form, k times 1, k times 10 plus 1, or k times 10 minus 1. Now, where the k is the seed number to be determined. Now, we should also take note here. It is of utmost importance to know that the value of k will usually be negative. Will be negative if the expression ends with plus 1, or then the value of k will be positive if the expression ends with minus 1. Okay, so that is what this place is trying to explain. Now, let's quickly move on. Now, let's look at some of the steps involved in generating seed numbers. The first thing to do is to choose two numbers that are odd prime, or two prime odd numbers. Okay, then you ensure that that their product will usually end with either 1 or 9. Then 3, express the result obtained in step 2 in the form of k times 10 plus 1 or k times 10 minus 1. Okay, now you should also know that there are usually two seed numbers associated with a given number. Okay, in this case, we are not going to look at 2 and 5. 2 and 5 are exception, because we have already know that it is very easy, to depict if a number is divisible by 2 and 5. Okay, for that reason, we're not going to look into that. Now let's look at detailed example. Let's find two seed numbers necessary to know if an integer is divisible by 3. Like we said, the first thing to do is to look for a number that will multiply another odd prime number that will multiply by the given number, so that the number will end with a unit digit of either 9 or 1. Okay, now here 3 multiply 3, that will give us 9. Then how do we express 9? So that it will become the form of k times 10 minus 1 or k times 10 plus 1. Here we're going to, the only way we can do this is k times 10 minus 1, which is 10 minus 1, that usually gives 9. That is, so 9 can be expressed as 1 times 10 minus 1. Now, please remember that your 1 here is the seed number, and here is plus 1, because the expression ends with minus 1. Okay, so here is plus 1. Now let's try another number that can multiply 3 so that the unit digit can become 1 is 7. So 3 multiply 7, that will give us 21. So we can also express 21 as 2 times 10 plus 1. 2 times 10 is 20 plus 1 is 21. Remember, the 2 here is the what we are looking for, and since this expression ends with plus 1, the value of k become minus 1. Please take note of this. You see, 3 times 7 is 21. In case we want to handle 7 too, so that means this one is also minus 2 is also a seed number for 7. Okay, so these two number here, 1 and minus 2, they are the two seed number for 3. Okay, let's actually try if 3 is divisible by 114 and 67. Okay, here merely looking at this one, it is divisible. 114 is divisible by 3, but let's show it clearly here. First of all, what you do, you look at 14, you look at the unit digit of 14, that is 4. You pick one of the seed number, which is 1. Let's use 1 first. 1 times 4, or 4 times 1 is 4. Once we use the unit digit to multiply the one of the seed number, we add the remaining the result to the remaining digits to your left. Okay, so here 1 times 4 is 4, then 4 plus 11 is 15. You see clearly that 15 is divisible by 3. Okay, if we see that thing, we can still try it again. 1 times 5 is 5, plus 1 is 6. We see clearly that 6 is also divisible by 3. Now let's try 2. Let's use 2 as another case study for 114. That is minus 2 as one of the seed number. So 4 times minus 2 is minus 8. 11 plus minus 8, that will give us 11 minus 8, that will give us 3. You see, 3 is also divisible by this. Now let's try the case of 67. Let's see if it is divisible by 3. Now the case, let's see the case 1, when the seed number is 1. 1 times 7 is 7. If we add 7 to the remaining digit, which is 6, it gives 13. So you see that clearly here, 13 is not divisible by 3. Okay, now let's try even minus 2 as the seed number. Minus 2 times 7 give us minus 14. 6 minus 14 is minus 8. So minus 8 is not divisible by 3. Please take note, the negative has no impact on what we are trying to do. What we are trying to look at, we are looking at a situation where the number, we want to know if the number is divisible by the number. So your result can be negative, but so long as it is divisible by that number, it means the number can divide that. Okay, let's quickly look at the case of one portion of 7. For 7 here, we see that the number that can multiply 7 so that the unit become 9 is 7. 7 times 7 is 49. And our 49 is the same thing as 50 minus 1, 49. So we can say 50 is 5 times 10 minus 1. So that's quickly give us that the seed number for 7 is plus 5, because this one ended with minus 1. So if we go back to 3, when we say 3 times 7, and the seed number is minus 2, so the two seed number for 7 are 5 and minus 2. So you can try this on your own. Look for those numbers that can be divided by 7. Try the two seed number 5 and minus what? Minus 2. Okay. So in this case, let's quickly look at this. 7. Let's try if 7 is divisible by 203 and 233. Now here, the unit digit is 3. 3 times 5 is 15. 15 plus the remaining digit, which is 15. The remaining digit is 20. So 15 plus 20 is 25. So 35 is divisible by 7. Okay. If we try further, we'll see that 5 times 5 is 25 plus 3, 28. 28 is divisible by 7. Okay. Now, if we try, let's look at the case. Let's look at the case of the number 232. Okay, let's see if it is divisible by 7. So the unit digit is 2. 2 times one of the seed number is 5. 2 times 5, 10. 10 plus this will give us 33. Please is 33. So 33 is not even divisible by 7. So in that case, it is not the 232 is not divisible by 7. Let's try the case. Let's look at for 11. Let's quickly find the two seed number for necessary for 11. Okay. So we can express 11 as 1 times 10 plus 1. So the seed number for 11 is minus 1. Okay. So the another case, what number do we use to multiply 11 so that the unit will end with 9 is 9. 9 times 11, 99. So our case of our 99 is 100 minus 1. So it's going to be 10 times 10 minus 1. So our seed number here is 10. So here the seed number is 10 and minus 1 for 11. Okay. Now let's test this. Let's quickly try this. If 11, let's try if 11 is divisible by 187 and 153. Okay. Now 7 times minus 1 is minus 7. So 18, the remaining digit is 18. 18 plus minus 1, that is 18 minus 18 plus minus 7, that is 18 minus 7 is 11. Okay, you see that one is the result is divisible by 11. So 187 is divisible by what? 11. Okay. Let's look at tried it with 10 in case 2 when the seed number is 10. So 7 times 10 is 70. 70 plus 18 is 88. The result is also 88 is also divisible by 11. Okay. Let's try for 153. Let's look at this. If it is divisible by 11, so the unit digit is 3. 3 times minus 1 is minus 3. If we add 15, the remaining digit is 15. 15 plus minus 3, that will give us 12. Let's see. That one is not divisible by 11. Let's try again. Let's try in case of 2 times minus 1. For this from this same number 12 is minus 2. 1 minus 2 is minus 1. It's not divisible. So the result is not divisible by 11. So 100 and 100 and okay, 153 is not divisible by 11. So this is all we can take on this. You can try other number on your own. Try 13, 17, and 19. Okay. See you in my next virtual class. Have a nice time.